Hello and welcome. Satellites. They play a crucial role in our everyday lives, providing us with communications and GPS navigation. What keeps them in space? What stops them from falling down in our heads? I mean, gravity's a thing, right? The answer? Orbital mechanics. Things in space may look like they're floating, but in fact they're falling, just like a thrown ball. They're being pulled down by gravity, as well as moving forward. In fact, if you compare the path of a satellite and a ball, they look surprisingly similar. The only difference is that when the ball hits the ground, the satellite doesn't, because it's moving so fast that the Earth curves away from underneath it. But hold on, this is rocket science. Surely it's not as easy as just throwing something into space. No. A satellite behaves a bit like a weight, tied to a string and being swung around. The shorter the string, the faster it spins. The longer the string, the slower it spins. This means that a satellite close to Earth will orbit a lot faster because it's closer, and a satellite further away will orbit a lot slower. However, it's not just speed that determines how long it takes for a satellite to complete an orbit. Being further away means that the satellite has to cover a greater distance at a slower speed. When all of these factors combined, it'll take the satellite exactly a day to orbit around the Earth. This is called a geostationary orbit. This means that from looking at the satellite from the planet, it would actually appear stationary. Whereas in fact, it's travelling at just over 3 kilometers per second. But that means it is also matching the rotation of the Earth. Being stationary relative to the ground means that the ground station doesn't have to move to track the satellite. This is actually why your satellite TV dish you might have at home just points towards the equator and never moves. Another benefit of geostationary satellites is that because they're so high up, they have a very wide view of the Earth, meaning that fewer satellites are needed for global coverage. However, the time taken to send a signal to the satellite and then receive a response can be quite long because the satellite is so high up. One way around this is, instead of having fewer satellites high up, you could have lots of satellites a lot closer to the Earth. This would mean that the signal time would be greatly reduced. However, a lot more satellites would be needed, since each satellite has a much tighter view of the Earth. Orbital mechanics plays a critical role in our everyday lives, and through our understanding of it, we can continue to propel ourselves forward into the future. Stay safe and remember, space is the one border we all share.